Hi guys, welcome back. Today I am going to be going over a relatively quick lesson on how to determine the shape of a graph. All of the graphs that I drew up here are histograms, but this also works on other types of graphs as well, especially like dot plots. It's all the same idea. I just wanted to show you on a histogram. I'll show you on a dot plot as well what it means. So there are 5 shapes that we're going to be going over that a graph can be, okay? They're skewed right, skewed left, normal, cluster, and uniform. If you would like to get a piece of paper and a pen down so that you can make a little chart of this, that would probably be very, very handy. Basically, what this means is where is most of the data falling into? What category is most of the data falling into? When most of the data falls into a certain category, it determines the shape of a graph. So as you can see, this shape, where it's going down like that, is very different than this shape where it's going up. This shape where it's going up and then down. This shape where it's just going up once. And then this shape where it's all kind of the same. All of these different shapes have a different name. Now, the first 2 that I'm going to go over are almost like the opposite of what you'd think, okay? So when I say skewed right, what that means is that the data starts skewing off towards the right or starts getting smaller towards the right. So data or shapes that are skewed right are bigger on the left and smaller on the right. So when it's bigger on the left and then it gets smaller, it is skewed right. Skewed right. What that means is that it tends to, it's up and then it goes down towards the right. It's up on the left and down towards the right. It gets smaller or skewed towards the right. Now the opposite of that would be skewed left. And what that means is that the data is smaller on the left and it gets bigger towards the right. A good way to find out the shape of something is to do what I'm doing. Just draw that line and see what shape that line is. So if most of the data is towards the right, it's skewed left. If most of the data is towards the left, it's skewed right. That's why I say it's kind of the opposite of what you'd think. Now the other 3 make a little bit more sense, okay? The other one is called clusters. So basically, when a lot of the, sorry, give me 1 second here. When a lot of the data is in like clusters or like little sections, that is called clusters and gaps. So basically, there's like a cluster right here, and then a weird little gap right there, and then a cluster right there, and then a gap right there. It's basically like the data just clusters up. It kind of goes together right here, and then you're gonna have a little break, and then it's gonna go together again, and then you're gonna have a little break, that sort of thing. That is called, I'll just call it clusters. I hope that you can read that. Clusters. Now, the next one, oh, that might be kind of hard to read. Let me see if I can close this a little bit to make this a little bit easier. I don't know if this is helping at all. Probably not. We'll see. We'll see what we can do. Oh, that helps. Okay, that's way better. Okay, the next data is actually like the most common kind. It's called a normal distribution. It's called normal, bell-shaped, symmetrical. You'll see all. I'm going to call it normal right now, but you should probably write out the other ones. I hope I'm spelling this right. Symmetrical. Those are really the 2 that you're going to need to know. And what that means is that the data is, there's fewer at the ends and it goes up in the middle. So normal is literally smaller at, I don't know why I'm making that little thing, smaller at the ends and then goes up in the middle. The last one is called uniform. And what that means is that everybody's about the same. All of the answers are all of the points have about the same amount of answers. Okay, I told you guys I was going to show you what it would look like with dot plots as well. I didn't include any labels on that because it says blah, blah, blah. I didn't include any labels on these because that's not really the point of this lesson right now. I just want to show you guys what it would look like. Okay, do not focus on exactly how many dots I have in each column or anything like that. That is not the point. It's just the shape of it, okay? So yours might have a completely different number of dots but be the same shape. That's why we do that trick where we draw the line over it and you can see what shape the line makes, because that's really how you would determine. So, like I told you, they're skewed right, skewed left, clusters, uniform, normal. I changed the order a little bit here just for the sake of space here, but I'm going to start with this top left one. I'm going to draw my little line to see about, okay, so we know it's high at the left-hand side. There's a lot of data points on the left, and then it gets smaller towards the right. Smaller towards the right is skewed right. So this one right here, skewed, right. This one right here, it goes small and then it goes up. What that means is that a lot of the data points are on the right-hand side. So a lot of my answers are on the right-hand side and it's smaller on the left-hand side. When it's smaller on the left, that means it is skewed left. Remember, it's exactly the opposite of what you'd think. If a lot of the answers are on the right, it's skewed left. If a lot of the answers are on the left, it's skewed right. I know it's kind of confusing, but you just have to study that, memorize it, and think about skewed as smaller, as getting smaller. Okay, the next one is this. So if I'm making this into a shape, it's going to be like, okay, it's big there, and then it's small there, and then it's big there, and then it's small there. All right, so when all of my answers are clustered like that, when they're in little groups together like that, and then there's random gaps in the middle, this is called a cluster shape. I'm going to be honest with you, the ones that are the most common that you're going to see, skewed right, skewed left, and then another that we haven't got to, but I'll show you in a minute, okay? The next one is this, where they're all just about the same. When they're all about the same, they're uniform. Think about that in terms of school uniforms. We don't wear them, but if you're wearing a school uniform, you all look about the same in terms of what you're wearing. When everything's about the same, it's uniform. So this is uniform. And our last one, where it's small and then big and then small again, is normal. This is the other one that you are going to see a lot that's actually really important. So this is basically what we expect data to look like. Because, okay, let's say that I'm asking you about height. Let's say I'm graphing people's heights. I expect most people's heights to be right about in the middle. There's going to be some people that are shorter. There's going to be some people that are taller. But most of the people are going to be right in the middle. That's the average answer. That's why this is called the normal distribution. This is what you'd expect a lot of answers to look like. Obviously, it depends on the question, but a lot of things that this is going to be what you expect it to look like. This is also called symmetrical. We've learned this term in class, but remember, something that is symmetrical is about the same. Well, it's really the same on both sides. If I were to cut this in half, it should be pretty similar on both sides. Obviously, it doesn't have to be exactly the same, but it should be similar. I'm going to try to link a PDF to these. There's going to be an extra one. You don't have to worry about it. Oh, actually, I should go over that really fast. I just want to tell you really fast. The highest point of the data sets are called peaks. So when you see the highest, that is called a peak. That's a peak. That would be considered a peak. Basically, wherever the highest point is. We've learned about that in ELA. The peak of the mountain is the highest part of the mountain. The peak of the data set is just the highest point of the data set. It's almost kind of like the mode, right? Okay, back to what I was saying. I'm going to include a PDF on Schoology, I think, if I can figure out how to upload it, of these, but also make sure that you're writing them down. Of course, as always, any questions, comments, concerns, anything, message me, ask me. I am happy to help. Stay safe. I hope to see and speak to you guys soon. Bye.